Our essential question for today is what trig ratios use the hypotenuse instead of both legs? So the first thing that I want you guys to do is I want you to draw this diagram right here, this right triangle diagram. We have our reference angle theta. We have the hypotenuse, which is the side length that's across from the 90-degree angle. And then relative to theta, the side that is across from theta is our opposite leg. And the side that is next to theta is our adjacent leg. So it's important for you guys to understand what the three different sides are in a right triangle, because based on which one you have values and variables for, that's going to tell you which one of our trig ratios to use. So just to recap, we already learned about the tangent ratio. So the tangent of your reference angle, tangent to theta, we abbreviate it TAN, and that's what it looks like in your calculator as well. It's the button says TAN. The tangent of theta is equal to the opposite leg divided by the adjacent leg. And we would use the tangent of theta to help us when we know the value of one and want to find the value of the other leg. So when we've got value and variable for the two legs, that's when we use tangent of theta. So now we've got our new one. Our new one is the sine ratio. The button on your calculator will actually just say SIN, but we still read that as sine of theta, not sin theta. So the sine of your reference angle is going to equal the opposite leg divided by the hypotenuse. So it's different than tangent because now we're using one leg and the hypotenuse, the opposite leg and the hypotenuse. And again, you will have a number for one of them and a variable for the other, and you would use this equation to help you solve for that variable. And our third new trig ratio is the cosine of theta. And in your calculator, it will be a button that says COS, but I don't want you to read it as cos theta. You should read it as cosine theta when you're saying it out loud if you're talking in your groups. Cosine of theta is the adjacent leg divided by the hypotenuse. All right, so these are the three trig ratios that we are going to be using in geometry. So now I want you to copy down this triangle, and we are going to use some trig ratios to solve for A. When you're doing these problems for me, the first thing that I want you to do before you do anything else is I want you to start by labeling the sides. Always start by labeling the sides. So here is my reference angle. For this triangle, my reference angle is 23 degrees. I'm going to label the hypotenuse first. The hypotenuse is always across from the 90-degree angle. And I just abbreviate it by saying HYP, hypotenuse. Then across from the 23-degree angle, that is going to be my opposite leg. And again, I abbreviate it. And then the leg that is next to the reference angle, the 23-degree angle, that is going to be your adjacent leg. So no matter what problem you're working on for me, I always want you to label those three sides because it's going to help you really see which trig ratio you should be using. Okay, now step one, I've annotated my notes over here so that when you go back and look at your notes, you can see what we were doing and not just see the math steps. But when you have it written out, like the actual steps you were taking, it will help you understand better what you did when you go back and look at your notes. So step number one, you are going to highlight the sides that are marked with a value or a variable. So if I'm looking over here at my triangle, I see that this length is 15, and I'm going to highlight that side. And it's already labeled as my hypotenuse. So I know that I have the hypotenuse as a value. The other side length that is labeled is this side, which has a variable A. So I'm going to highlight that side. That is my opposite leg. Notice there is nothing labeled on my adjacent side. So step number one is to highlight the sides that are marked with the value or the variable. All right, now step number two says choose which ratio to use. So based on what I have here, I'm going to take a look at my three trig ratios, and I'm going to look for the one that has the opposite leg and the hypotenuse. So if I go back up to my trig ratios, I see that the one that has the opposite leg and the hypotenuse is my sine of theta. So opposite and hypotenuse is in the sine of theta. So I'm going to use sine of theta. Okay, step number 3, write the equation. So my equation is going to be sine of, I'm not going to put theta in there because I know theta is actually 23 degrees. It's this 23-degree angle. So I'm going to say the sine of 23 degrees equals the opposite leg, which for this diagram is marked with the variable a, divided by the hypotenuse, which is marked with the number 15. So I write my equation. Sine of 23 degrees equals a divided by 15. Now, my next step is to get the decimal from my calculator. So now I'm going to get my calculator out, or I'm going to go to desmos.com/scientific, and I am going to put sine of 23 into my calculator, and it is going to give me the decimal version of that ratio. And I'm going to write it down here, but I'm also going to keep it in my calculator so that I can just use it without having it rounded. Because as soon as you round something, you lose a little bit of accuracy. Notice nothing on the right side of my equation changed at all. The only thing that changed was I went to my calculator and I got the decimal version of sine of 23. All right. Now my final step is to solve my equation for my variable. My variable is a. It is being divided by 15. To get rid of division, I multiply by 15. And that will cancel out with the divided by 15. And then I need to multiply the left side by 15 as well. So since I kept that accurate value in my calculator of what I got when I did sine of 23, I can keep that and just do times 15 so that I'm not losing any accuracy by rounding. And when I do that, I end up with 5.86. Now at this point, since it's my final answer, I'm going to round it to the hundredths. It's 5.8609. So to round it to the hundredths, since 6 is followed by a 0, I just keep it 6. And the right side of my equation was my variable a. And there is my answer. Here I have another triangle. I'm going to start by labeling the reference angle, which is this angle right here, labeling the hypotenuse, which is always across from the 90-degree angle. The side that is across from my reference angle is the opposite leg. The side that is next to my reference angle is the adjacent leg. So always start by labeling your 3 sides of your triangle. And then we're going to highlight. I have this value of 8. So I'm going to highlight that side that's marked with the value of 8. That's my hypotenuse. I have this variable right here, b. So I'm going to highlight that side. That's my adjacent leg. So by highlighting, I can kind of look and see what I have the values and the variables for, and that will help me decide which trig ratio to use. So I have hypotenuse and adjacent leg. So I go back up to my 3 trig ratios and I see which one has hypotenuse and adjacent leg. There's adjacent and hypotenuse. I'm going to use cosine of theta. So now I'm going to use the cosine ratio. So next step is to write my equation. Cosine of my angle is 37 degrees, is going to equal the adjacent leg, which in this case is my variable b, divided by the hypotenuse, which in this case is 8. So there is my original equation. Cosine of 37 equals b over 8. My next step is to go to my calculator and type in the cosine of 37 and get this value written out as a decimal, 0.79 8, 6, 3, 5, 5, 1. I'm going to kind of leave it at that for now, but I'm going to also leave it in my calculator and round at the very, very last step to make sure that I keep it as accurate as possible. The earlier you round, the less accurate your answer will be. If you can keep from rounding until the very end, your answer will be most accurate. All right, I did nothing to the right side, so I still have b over 8. Now I have an equation that I can solve for b. It's being divided by 8. To get rid of that division, I would multiply both sides by 8, and that would get rid of the division. And since I kept the cosine of 37 in my calculator without clearing it, I can just do times 8 and it'll pull that answer down and gives me 6.38908. I'm going to round it to 2 places. So 3, 8, and then the number to the right of 8 is 9. So that means I got to round that 8 up. So it's going to be 6.39 equals B. And there is my answer.